Hey everyone, considering for application of differentiation, we have to go back to the definition of differentiation, the rate of change. Unlike the definition though, we are actually going to extend this to more than two variables. So we're not just limited to y or x or a or b, we're actually going to expand this to actually more than two variables. For the A-level H1 and the A math students, it's only going to extend until the three variable, so y, x, and let's say common time t, or let's say volume, area, and radius. For the H2 math, you might get more than three variables, let's say 3 or 4, but ultimately you'll boil down to three variables at the end towards your final answer. But nonetheless, don't be intimidated. These logics are actually pretty intuitive, pretty easy to understand. Just that when you apply them, just be careful because the derivative might be complicated. Do not make any careless mistakes when you're trying to add in the value, substitute the value. Nonetheless, I'll explain the basics right now. For the H2 math students, there'll be one more video for you guys talking about implicit differentiation, talking about higher order of rate of change. Not to worry. So let's start. So rate of change. So let's use this first example, y, x, and t. So we talk about y, x, and t. T is time. Therefore, what is the real life example I can think of right now is speed. All right. Let's say y is a speed and x is something. Okay. So how do you represent rate of change? So if y changes with time, and if x changes with time, we say dy dt, dx dt. Same thing as your definition for differentiation, right? How y changes with respect to t, so therefore dy dt. How x changes with respect to t, and therefore dx dt. In the A math and the H1 math syllabus, these values are usually given, and if not, you have to find these values, all right? But nonetheless, keep it simple. Let's say y increases by 3 units per second, and let's say x decreases by 2 units per second. All right. So with dy dt, how y changes with respect to time t, I know that y increases by 3 units per second, therefore 3. If x decreases by 2 units, so it's decrease, negative sign, 2 units per second. So how does this relate to your dy dx? Because there must be a reason why the question gave you the values of these two, is for you to find out the value of another variable or another derivative, and that derivative would be your dy dx. So how do we relate dy dt to dx dt, right? Very simple. Dy dt over dx dt. Why is that so? Go back to the definition of your differentiation or derivative. Dy dx is basically the rate of change of y with respect to x. If y changes to a variable, so in this case, y changes with respect to t, right? And if x also changes with respect to the common variable t, then however y changes with respect to t over however x changes with respect to t would give me how y changes to the corresponding x, correct? Because they both share the same type of comparison, which is the time. And as such, if you have dy dt over dx dt will give us dy dx. Therefore, if you notice, we can kind of treat this like a fraction, right? Dy dt divide by dx dt, okay? Because this is the first derivative, dx dt equals to 1 over dt dx and vice versa. So dt dx equals to 1 over dx dt. I then have dy dt times dt dx. And therefore, if you notice, although don't do this in your exams, do not go and cancel. I cancel dt below, I cancel dt on top, I get dy dx. I can manipulate this a bit, and I get dy dx times dx dt equals to dy dt. Notice I cancel dx in the denominator, I cancel dx in the numerator, I get back dy dt. Again, do not cancel. They are not fractions, they are functions. All right. So this is just the general introduction. I'll show you one more example, and then we'll call this video off, and then I'll proceed on to more actual examples like questions. All right. So talking about volume, area, and radius, right? These are the two most common ones in your questions. Obviously, we're not American, so we're not going to compare like, how many desks per swimming pool, so don't worry about that. But back to this. Volume according to radius, so how volume changes according to radius, and then you have your area according to your radius. All right. So let's see if I find dV dA would then be the same thing. So dV dr times, okay, dr dA. All right. And of course, you work it out. You are likely to be given this value. You're likely to be given this value, and then you have to find this value right here. If not, then the opposite will kind of happen. They will give you this value. They will not give you this value, and then you have to kind of they will give you these two values, and then you have to find this value. Of course, then the other things can happen as well. If they can give you this value, they can give you this value, but you have to then find this value. So it really depends. For the H1 and AMS students, and sometimes the H2MS students, you're given, this is obviously your set of questions, right? They'll give you either any of the values, two of the values, and then find the third one. But for the H2MS students, then you might not get these questions more often than not. Okay, so yeah, this pretty much sums up this rate of change video, and yeah, hope you enjoyed it.